All right, hello everyone. Today's video topic is on classification and properties of numbers. So this is a beginning algebra topic. So how we're going to start. When we classify numbers, there's two big categories we mainly focus on. So we have our real numbers and our complex numbers. Any number is going to fall into one of those categories. Biggest one is that real numbers. As you can see, we have all these different types of numbers kind of subsectioned within one another. So when we're talking about these, the smallest, like most specific category, I guess we could say, is our natural numbers. What these are, people sometimes say like counting numbers. So think like 1, 2, 3, 7, 100. Any number that, like a full whole number that you would count with, no fractions, no decimals, no negative numbers, and no zero as well. When we move up to our whole numbers category, it's the same thing as natural numbers, except we're going to include zero. Okay? So what you're going to notice is every time we move up a category, so from natural to whole, from whole to integers, all like natural numbers are included in the whole numbers, and all whole numbers are going to be included in integers. So it's kind of like, okay, integers is going to be all of this. Whole numbers is going to be all of this, if that kind of makes sense. All right, so speaking of integers, what's the difference between a whole number and an integer? Well, an integer, it includes 0, 1, all those whole numbers. It's also going to include negative numbers. So 0, 1, 2, 3, which are whole and natural numbers, but integers include the negatives as well. Something to note, we're still not using any fractions, we're still not using any decimals. All right, so those are the first three. Then we have rational numbers. Rational numbers are going to be some sort of like fraction or decimal. It doesn't matter if it's positive or negative. What matters is we know the full decimal, like it either ends somewhere or it repeats in a pattern way where we could like know what decimal place value is what number. So here are some examples. Negative 3.64. That's just a plain old negative decimal. It ends after that 4, so rational. If we look at a fraction, such as 5 over 8, well, that decimal is 0.625. That decimal, we know it cuts off, we're good. If we have a repeating decimal like this, what that line above the 4.2 means is that this 4.2 value repeats and repeats. It alternates 4.2, 4.2. This is technically rational because we could look at any place value. We could say, oh, what would be the fifth? We could say that's a 4. 6 would be a 2. So it kind of repeats itself. Irrational, a lot of, well, main one you're probably going to know is pi, right? Pi is 3.14159, da 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 da. It's a decimal that repeats, but there's no pattern to it. We can't just predict what like the 100th number is. Also a lot of like square roots sometimes, like root 2, root 5. Those are also going to be irrational. Okay, those all technically are real numbers. So again, we have our real numbers, which include all of these things. Rational numbers include all of this stuff. Okay, integers include all of this. Whole include all that. Irrational is kind of like a separate category. Okay, now if we want to move on to complex, well, this is something you might come across in like later algebra. So if you haven't reached here, you're not really like sure what this is, don't freak out, stay with me. Basically, complex numbers have something called I, or the square root of -1. So some value of a negative square root or an I is going to make that number complex. So a lot of times you're going to see these, for example, 3 minus 4i, 7 plus 2i. So if you see this I value, that means we're talking about a square root of a negative number. You might know, technically we can't have the square root of a negative number, so we have an imaginary number, which is what that I stands for, imaginary. You can combine this with other things too, like root 3 minus 5i, doesn't matter. We have to have that imaginary number in there, the square root of a negative. Okay, so now that we know our types of numbers, we are going to be looking at the properties of real numbers. So let's actually go back. Recall this. These are the real numbers. So basically, these properties we're going to talk about, they're going to apply to everything except complex. All right, so when we're looking at these properties, we're going to kind of have two categories. We're going to have the property, and we have the addition part of the property and a multiplication part of the property. So when I write these out, I'm going to write them with like variables or letters, and then I'll give an example with actual numbers. So commutative property, this one's pretty basic. If you have two numbers and you're adding them together, it'll get you the same thing if you add them in the reverse order. So a plus b equals b plus a. Common example, 5 plus 3 is 8. That would be the same thing as doing 3 plus 5. They're both going to equal that same thing. Multiplication, same idea. When we're multiplying two values, we can also multiply them in the reverse order. So, again, if we have 5 times 3, that equals 15, which is the same thing as 3 times 5. Let's note for a second, these properties are only for addition and multiplication. If you try to do this with subtraction or division, they're not equal. These don't work. So only for addition, only for multiplication, you can use these properties. All right, associative. This is for when you have three or more, technically, numbers. So if we're adding 3 numbers together, technically we could add the first 2 first, and then add that to the last, or we could add the second 2 first, add that to the first. If that it's just whatever order you're multiplying them or adding them. So if we have 2 plus 3 plus 4, well, we could add those first 2 numbers first, which would be 5 plus 4, which is 9. If we added the second 2 first, so 2 plus 3 plus 4, if we added 3 plus 4 first, that would get us 2 plus 7, also equal to 9. So it doesn't matter, like if you want to add the first 2 numbers together first or the last 2, doesn't matter. It's addition. That kind of goes back to the commutative property. You can flip the order of what you're adding. All right, similar idea, but for multiplication. Except we're multiplying 3 values together. Okay, you can either multiply the first 2 together first, the last 2 together first, it does not matter. So, going into an example, we have 1 times 2 times 3. You can think of that as, well, 1 times 2 is 2, times 3 would be 6, or you can think of that, okay, 2 times 3 is 6, and 1 times 6 is also 6. So those two methods, we're doing them a little bit differently, but we're still going to get that same result. All right, identity. So the identity property is basically saying if we start with a number And since this is addition, what can we add to it in order to get itself back? Think about that. What can we add to A to get A? Don't overthink it. Add nothing, add 0. So the identity property just says if you add 0 to any number, you're just going to get what you started with. For multiplication, it's going to be the same idea. What can we multiply by to get itself back? What can we multiply by A to get A? The answer is 1. So an example would be 3 times 1 equals 3. Note that these are two different things. Here we add 0, here we multiply by 1. They're not, the identity isn't the same for addition and multiplication, so just keep that in mind. All right, we are getting there. Next. All right, next we have the inverse property. So what this says for addition, oh my gosh, okay, if we have A, what can we add to A to get 0? So what we're doing is we're taking our identity value for addition and we're trying to get that instead. So what can we add to A to get 0? This is kind of tricky until you see it maybe. The answer is just the negative value, negative A. So what would be an example of this? Well, we have 2. We can add a negative 2. 2 plus negative 2, those cancel each other out, right? That's like 2 minus 2. That's going to get us that identity of 0. All right, so let's think of the inverse for multiplication. We have A. We want to times it by something to get 1. Remember, 1 is the identity for multiplication, so we want to get 1 as a result. So take a minute, think, what can I multiply A by to get 1? Okay, that's going to be 1 over A. There's one rule to this, though. It's very important. As long as A does not equal 0, right? Because what happens if we have 0 in the bottom of a fraction? Well, go ahead and put that in on your calculator once. 1 divided by 0 is undefined. So we can never divide by 0. So as long as A doesn't equal 0, this is the inverse. All right, so, and actually if A equals 0, right, if this is 0, we can't multiply 0 by anything to get 1, because anything times 0 is going to be 0. Little side note there. So, an example, well, if we have 2, we do 2 times 1/2, that's going to get us 1. Remember, if you want to think about this in like terms of multiplying fractions, we can think of 2 as 2 over 1. When we multiply fractions, we're basically multiplying straight across. So 2 times 1 is 2, 1 times 2 is 2, 2 divided by 2 is 1. All right, and last property is the distributive property. What this says is if we have a number multiplied by 2 numbers being added together or subtracted, you could do any of this. What you can do is we say distribute this outside term, multiply it by the first value, multiply it by the second. We have A times B is A times B or AB. Our symbol is plus, so plus, then we have A times C, AC. Okay, let's see how this would work in an example. So we have 2 times 1 plus 3. Okay, well, there's technically 2 ways we could solve this, right? We could say, well, what's 1 plus 3? Okay, 1 plus 3 is 4. What's 2 times 4? Well, 2 times 4 is 8. Okay, but that works, but what if we wanted to solve it with the distributive property? Okay, so what we would do is we take the 2, distribute it, so multiply by each term. So we'd have 2 times 1 is 2. So 2 times 1, our symbol is plus 2 times 3, which is 2 plus 6, which also gets us equal to 8. So that is our distributive property. So remember, these are properties of real numbers. They only work for addition and multiplication, so don't try to do some of these with subtraction or division. They're not going to work. All right, that's all I have for now, and I will see you next time.